All right. So, hello everyone. We are meeting after quite a bit of time, but I hope that you have sort of gone through the things that we have done so far. There were a few things that I had given you to read earlier, and I hope you have done those things. If you have not done those things, then this might be a good time to quickly go back, finish those things, and then start looking at this video. Okay. So there was a bit of gap since I had some work, but now we are back to the course and we will continue now. Okay. And hopefully there will not be any more gaps in between. So we were working with linked lists, if you remember correctly. And we did an overview of linked lists and how different data structures can be represented using linked lists, right? Using keys and pointers and things like that for some special examples. So we had looked at binary trees, we had looked at arrays, we had looked at stacks and queues. We had also looked at how to insert elements, how to remove elements and all those things, right? But those we did in an informal setting. We drew diagrams and then we saw how they have to be done in those diagrams. It's time to now we understand informally. Now we have an idea of what these things are. Now we need to be able to do these things formally. Okay, so for beginning, I think one of the sorting algorithms we did write down. We did look at the algorithm which was given in the book, and I explained you the algorithm. I think it was for merge sort. Similarly, for linked list, I think one of the examples of linked list inserting and deleting, uh, we did look at the formal algorithm for how to do it, right? And now we have to sort of go ahead and do these things for the remaining data structures also. So that will complete unit 3 for us. Okay. So let me start with linked lists again, but this time formally. How will you represent a linked list formally? Formally. Okay. So I hope you guys are seeing the screen, and I'm trying to on one side I draw some linked lists the way we have seen drawings before, and on the other side I will write down the corresponding code so that you understand what is the how things correspond to each other. Is that okay? So let's begin with the basic thing that we had. Let's begin with an array, okay, and not something very different. So now I'll use circles sometimes to show objects, okay, and we'll go slowly. So take your time in understanding what we're doing here. We'll go slowly. That's why I'm drawing with you instead of drawing things beforehand. Okay. So what does a simple array look like as a linked list? So we have these boxes. These boxes are the arrays. So they have index, right? Not the value in each of these cells, but the index. So what's the index? So index is 1. I hope you guys can see this well enough. Okay. Increase the font size. That's good. This is the second array cell. Right? So I'm drawing this so that things are going at a leisurely pace. Feel free to fast forward a little bit in between if you're finding this really slow. We have index 4 and we have index 5. Right? So this array has 5 elements, but these are the indexes of those elements. What are the values? The values will give some values. So let's say 7 or 6, 2, 3, 45, 0. Okay, these are the values. And we have these indices 1, 2, 3, 4, 5 to show which number cell it is. Right? So we already have an order among the cells. And therefore there is nothing of, there is no linking required. There's no separate linking required. The links are already there. So that is as good as saying there is an edge of this kind, from there's just an edge between these two which need not be need not have any arrow between them, because the arrow is clear. The arrow is obvious from the arrow is obvious by looking at the indices 1 to 2 to 3, 3 to 4, 4 to 5. Okay. So it's as good as just having a plain edge without any arrows between them. Okay. So this is a simple array. Okay. So let me also give this a name. So the array has a name A. Okay. And these are the values. A of 1 is 6, A of 2 is 23, and so on. Okay. So let me save this. I'll share these files with you later on so that you can refer to them later on. But for now, let's keep them. So, all right. How is this as a code? As a code, the array, there isn't much, right? Do you see? So, as a code, so, oh, I think this font size means. Yeah. So, the array, there isn't much here. It's just A equal to, I put a semicolon in order to mark the ending. What is the first value? 6, 23, 10, 45, 0. That's it. You see, the index need not really be written. The index is obvious. When you write it this way, it's obvious that the first element is 6, second element is 23, third element is 10, fourth element is 45, fifth element is 0. Right? That's why you don't need these directions either. It's obvious. That's why I have simply drawn undirected arrows instead of directed arrows. Okay, is that clear? So array is simple. Array is just this much. Now I told you that it's possible to write down an array as a linked list by just introducing arrows, even though they are not necessary, if you remember. Okay, so let's try to do that. So let me save this as a new file before I make any changes. Calling this array forward, because if you remember, there were two kinds of arrows that we could draw. We could have made it forward arrow or backward arrow. Remember? So let's do that. So you see, now there's a forward arrow. There is a direction to this. I hope the array, the arrow you can see clearly. And now we have these arrows, directed arrows, right? How will we represent this as a linked list? This is a linked list properly. This is different from what you saw before. Okay. So this array as a linked list, let's say forward directed. How will you write this? Now here is where you needed pointers, right? These arrows are basically pointers. So you needed to know what is pointing to what. So now array is not a single array. There are two arrays required in order to write this. Why? The indices are obvious, 1, 2, 3, 4, 5. It's always obvious. Okay. The values are there. That's one array. But now you need to store the pointers also, the next pointer, if you remember. So in order to store the next pointer, you need one more array. Is that okay? So now in this case, we will not have a single array A. So here's one thing to note. Just as we write these linked lists, in a computer or when you write it as a program, a simple array, the kind that you see here, a simple array is the only one that is already present or can be assumed. Every other linked list you have to obtain using these arrays in some or the other. Okay, you use these arrays to construct other kinds of linked lists. Is that okay? So now when it's forward directed, what does it mean? Now there is a direction, so there is a next pointer. So the in-between values, the values that are stored in the array, we'll give it a name. We'll call them key. Okay. Key means the inside values. These values, 6, 23, 10, and those. In the simple case, we did not need to write key because A itself, so A is equal to A dot key. All right, so I'm not writing it that way. Okay, so maybe I just need to shift the windows a little bit so that you can see the whole thing. Okay. Yeah, this is fine. Okay, so key. But when you have key, okay, so what are the key values? The key values are the values. So in the first array, you have 6, you have 23, you have 10, 45, and 0, as they were before. But that's only the simple array. Now you want to give these directions. Directions are the next pointers that you have. A dot next, right? So what is that equal to? So let me make the spacing. Okay. So when you look at A dot next, what is it? Again, the index is obvious. The index values are obvious, right? They're always assumed. So now the question is, for the object with index 1, what does it point to? It points to index 2, right? It points to the object with index 2. Therefore, the next pointer value is 2. Now, for the object with index 2, what does it point to? It points to an object with index 3, right? So for A dot next, the value at the place 2 is going to be 3 because it stores the value of the next object. Similarly, 3 will point to 4, 4 will point to 5. What does 5 point to? So let me also make the spacing accurate. So this makes it easier to see. What does 5 point to? 5 does not point to anything. And that is where we used this symbol backslash, right? Empty. Remember there was an empty symbol, empty pointer. It does not point to anything. So this is what it says. The next values are the values which tell me which is the next object that is being pointed to. So again, when you read index wise, the object at index 1 points to the object at index 2. Object at index 2 points to the object at index 3. Index 3 points to index 4. Index 4 points to index 5. Index 5 points to nothing. That's why you have the empty pointer. Is that okay? So that is what this is. So now since we also did the backward form, right? So array as a NL linked list backward directed, right? Since we are doing the first two examples, I'll also do the backward one, but you should get a hang of what these things are, okay? So I'll also do the backward one. LL, backward. Now we get rid of these arrows. Now we have backward arrows. Right? Right. So now when you write these as backward arrows, what is this going to be? So take a time. So pause this video, take a time and think over what it should be. I'll just write it down quickly so that we can move ahead. So the key values are going to remain the same, right? Because the contents of the array don't change. And instead of next, now you have previous because you're going for the previous thing, right? The arrows have to point to which is the previous one. So the index one object points to nothing. There's nothing before. The index one object is not pointing to anything before that. So that is where you have the empty pointer, the empty previous pointer. Object at index 2 points to index 1. Index 3 points to index 2. Index 4 points to index 3. Index 5 points to index 4. Understand? So, is that okay? So that is what it is. Just think over it and whatever I described in the earlier example, just run through it once. Think over it and this is what it will look like. Is that okay? Right. Finally, we did a second variant called doubly linked list. This was singly linked, right? We also did a doubly linked list. Okay. So that I will leave now. And should we do it? Let's do it. Okay. Anyway, since so let's do it. So I'll show doubly linked list to you. So let me save this and doubly linked. Okay. And now we have two sets of arrows. One is forward and one is backward. Right? We have two sets of arrows. So also increase the spacing. Is that okay? So that's the doubly linked list representing an array. So how would that look like? Array as a linked list, but doubly linked. Okay, the previous ones were called singly linked. Is that okay? So now what do we have? Well, we will have a dot key as usual, which is 6, 23, 10, 45, 0. But now what do you expect? There is an a dot next. Okay, so let me just leave it for now. And there is also an a dot previous. There are 2 pointers, right? Now, if you look at it, you're basically repeating the same thing twice, right? The previous two things that you've seen, you're putting them together. So if you look at next pointers, first one is going to point to 2, second one will point to 3, third will point to 4, fourth will point to 5, and fifth one cannot point to anything. There is no next element, so empty. Previous ones, first one is not pointing anywhere. There's no previous element. second one points to 1, third one points to 2, fourth one points to 3, and fifth one points to 4. Is that okay? So that is how you simulate it. That is how you simulate a doubly linked list as an array, right? So now henceforth, so now you know what doubly linked and simply linked is. So I hope I've given this simple example, but now I'll expect you to be able to write down a doubly linked version of anything that I give you in singly linked form. Okay. So now let's do this. So let's do a new one. So these are say binary tree. Okay, that's the other thing we separate. So let's do a binary tree. Repeat everything. It's a tree, which is T. Okay. So now once again, feel free to fast forward if you don't want to follow this, but I'm just drawing it for your convenience. So we have so I draw two levels. Okay, so that how do you want to draw more levels? Okay, let's stick to this one. No, let's see. Okay, so let's draw 8 instead of maybe that will make things easier also. Okay, so we'll have 4 more to remember, right? Binary trees have lots of children, right? Every vertex has 2 children. That's how we draw them. So this one has 2, this one has 2, this one has 2, and this one has 2, right? What are the arrows? So I'll draw one version. The other versions are similar, and I'll leave that to you. Okay, to draw as well as to write down. Let's do the doubly linked version because that is probably more difficult rather than the singly linked one, right? So from here to here. And if you can draw the doubly linked version, then you can also draw the singly linked version. So that should be it. So these are the 2 children, right? What about the parents? And the parents are also there, right? Doubly linked means the vertex also points to who its parent is, right? That is one set. And we have similar sets later on. So, okay, fast forward if you want to go ahead. But, all right, so just All right, so why don't you try finishing this diagram on your own? Okay, try drawing this on your own, and then we'll move on to the code. I'll finish drawing this and then write down the code rather than putting it on video. I'll cut the video now, finish drawing, and get to the next part of this video. Okay, so this video stops here, and we'll soon meet with the completed diagram. Okay, then. So thanks.